Welcome everyone. As people start coming in, we'll just give a couple seconds here, and then I will be going over a little bit about Minnesota LTAP and what the course is, a Zoom tutorial, and then going over our instructor Brian Jackson. So we'll give a few more minutes, not even minutes, seconds. And as people start logging in here, again, welcome to the Minnesota LTAP sponsored Gravel Roads webinar. This is our last one in a series of 4. The other ones are all posted on our website, so you can go and view those. This one will be posted next week. And so if anyone misses it or they want to come back to it, it's going to be available for everyone starting next week. So let me start sharing my screen here, and I'll introduce myself. I am Catherine Stanley. I am with Minnesota LTAP, and I'm the LTAP coordinator. Okay, again, welcome everyone to the Gravel Roads webinar series. As I mentioned before, this is the 4th session. Today we're focusing on hills, super elevations, and intersections. So this webinar series is presented by the Minnesota Local Technical Assistance Program, which is located at the Center for Transportation Studies at the University of Minnesota. Minnesota LTAP is sponsored by the Minnesota Local Road Research Board and the Federal Highway Administration. So Minnesota LTAP was established in 1992 by the Federal Highway Administration and in partnership with Minnesota's Local Road Research Board. Minnesota LTAP is one of 52 LTAP centers nationwide. We are designed to provide local transportation agencies with the tools for improving operations. LTAP's ultimate goal is to foster a safe, efficient, environmentally sound transportation system by improving skills and knowledge of local transportation providers through training, events, demonstrations, technical assistance, and technology transfer. So as you can see, Minnesota LTAP offers a variety of training and educational opportunities year-round, from annual events to a variety of technical workshops. So this particular webinar series is inspired by our one-day gravel roads maintenance and design workshop. And we also have several online courses that are self-paced and available whenever you're ready. So Minnesota LTAP has a variety of newsletters, reference documents, videos, a website, and provides library services and technical document searches. So if you haven't participated on a Zoom webinar before, this is just a little high-level overview as a participant. So here in the chat feature, you can talk to just us, the panel, or you can talk to your fellow participants. So if there's anything you want to communicate about best practices, a link, something that worked for you throughout the presentation, please don't hesitate to use the chat feature. If you have a specific question, please submit it under the Q&A. We will be answering those as they come in. And then also, if you need to leave the meeting at any time, go ahead and select this option. And once you leave the meeting, you'll be prompted to complete an evaluation form. That would be very wonderful. It helps us to identify new training opportunities and understand your exact needs. Now, to introduce our instructor, this is Brian Jackson. So he has been a heavy equipment operator for 30 years. He also served in the Navy, becoming certified in 49 different pieces of equipment. He worked at Fillmore County, Nebraska for over 20 years. He's also a former motor grader operator instructor for Nebraska LTAP, and Minnesota LTAP also uses him for our grader training. And in 2019, he started his own training business, providing equipment training across the Midwest for counties, cities, and state employees on virtually all pieces of equipment. So that is our instructor, Brian Jackson. So I'm going to hand it over to him. And again, please submit questions throughout the conversation. If you want to chat with fellow members, go ahead and do that. This is also your training, so don't be shy. We answer all the questions we can. If we can't get to them during the session, we can follow up with you afterwards. So Brian, it's all yours.
All right, sounds good. Thanks a lot, Catherine. I just want to say thanks to everybody for joining us today. This is our 4th session of the Gravel Roads webinar series. We've kind of touched on a little bit different topics all through the sessions. Today we're going to talk about super elevations, hills, and intersections, which can all be very difficult to train on and to maintain. About your instructor, I have been a heavy equipment operator for over 30 years. I've actually started training operators on a volunteer basis in 1999 for Nebraska LTAP. I did a full-time position with them from 2015 to 2019. From there, I started my own business. I've seen a huge need for operator training and a huge demand for it. I'm really passionate about what I do. I really like to take a lot of time and spend the time to train operators and make sure we show them good techniques. And all in all, it's, overall, it's to build a safer transportation system and be cost effective and efficient about it. Why did I pick this topic today? Super elevations, intersections, and hills when we do training. They're always a big topic when we come out there, how to properly maintain them, how to keep them in shape. And they can be difficult to do. All of our topics so far have kind of led up to these topics. And like I said, the importance of training. It's really important to take the time to train your operators, set some guidelines for them, give them some objectives to strive for when you're out there. Because all in all, we want to build that safer transportation system. We're going to start off today with a poll question before we get into super elevations. What is the device used to determine the safe speed of a curve? What is that called? There's some different methods out there that you can use when you're out there to test the safe speed of a curve. So I would like to kind of see what the audience feels would be a good, simple way to test the safe speed of your curves.
Okay, great. So I just launched the poll. So we'll give you guys about a minute, or unless the submissions slow down, and then I will share the results.
Oh, it looks like we're getting a little bit of varying answers while we're out there. Looks like the majority right now is going for a ball bank indicator. So there are different methods that you can use out there, but there are some techniques that you can do to help yourself out, because along with super elevations, making sure they're properly signed, properly posted for the proper speed and stuff, all really important. So.
Okay, so I'm closing the poll. And so looks like 67% said ball bank indicator, followed by 19% with slope meter.
And the correct answer is a ball bank indicator. That measures the degree of a curve to help establish a safe speed. A slope meter actually that looks like the slope. You're trying to run a 3-to-1, 4-to-1, 5-to-1 slope. Your 4 slopes. That's actually what that's used for. Slope meter number 2. And there's a huge difference between a slope meter and a slope meter number 2. A slope meter number 2 actually will gauge the cross slope on your road top. So, if you're using one of those instruments, make sure that your operators have the right ones when you're gauging the cross slope of your road. But it's a ball bank indicator that uses a degree to test the safe speed of your curves. And you can refer back to your MUTCD. They give you good guidelines in there on how to use one. On how to test it, how to start off with your speed. It's really a helpful source if you want to check your curves and stuff while you're out there. And it's an effective way that counties and locals and entities can go out there on their own and do that. All right, our super elevations. We've got our normal crown of our road that we're running, and we got to begin that transition into our super elevations. There's different things in different manuals when you go out there as to when you should start that transition. Some of it depends on the variety or the severity of the super elevation or the curve that you're working on. Some manuals out there say 50 to 100 feet. Some say begin to start the transition about 100 feet. I think a good indicator is the very minimum you should try to do 100 feet. To begin that transition into a super elevation, you should really begin farther, maybe about 300 feet. When you start to begin that transition, it takes time to change that transition into that curve. And when you think about it, if you're setting your guidelines at about 100 feet and some of the different things like that, that's really not very far. That's only about 33 yards. And when you're in a machine, that's really not a lot of room to begin that transition into your curves. But as you begin that transition into your curve, you slowly start to press down on the hill of your machine, and you gradually raise the toe or gradually raise your toe So you got to begin that transition in there. When you look at super elevations too, some different diagrams of super elevations, they'll show a separate shoulder area on the outside of the curve. Some show it without. They'll run the super elevation all the way from the bottom side of the curve all the way to the top. But it's important to make sure that you take the time to make that transition in there. There can be a lot of issues with super elevations. You want to make sure that the back side of that super elevation doesn't drop off. You want to make sure that you slope it and you get it all the way into the end. If you go through, there's different manuals and stuff that's, what's the major cross slope that you run on a super elevation. Some say 8%. A good guideline maybe is to try to keep it around 6%. Definitely not try to exceed 8% on your cross slope on your super elevations. One of the big things, like when we take pictures like this, is super elevations can be really tough to maintain. Our traffic really likes to cut the inside curve, and we continually cut it down. And we always got to be thinking about drainage and stuff when we're out there. There's a lot of different techniques you can use to try to keep your traffic out to and on your super elevation. Maintaining the inside of that super elevation, the ditch, because drainage is really important. And on your super elevations, a lot of times that material and stuff is going to it'll work down towards the bottom, especially if you get some heavy rains and stuff, it'll wash that material down. So it does take time to go out there and maintain your super elevations and to bring that material back up and incorporate it on the road. If the backside of your super elevation tends to drop off a lot, there's a lot of several methods that you can use to bring that back up and to reshape your super elevation. A lot of times you can bring that up from the outside of the curve, or when we take a look at this super elevation here, we have a lot of good material on the inside of that curve where we could come in and cut that and bring that back up and reestablish a good hinge point for our road, and to actually use all that material and reshape our super elevation. When we take a look at this one here, this, you can see how we're getting the water is washing down. If you look at the outside of this curve where that vehicle's parked, it actually drops off on the back side of that super elevation. One of the things you got to look at is, what are we running for a cross slope on this road? We may need to look at, are we running maybe too much cross slope? Maybe we're running 8%, maybe we're running 10%, but we definitely don't want to see that 8%, but we might want to try bringing that back down to 6%. One of the important things that you could do in here is this, as you could tell, traffic is always cutting the inside of this curve. It always goes down. There's really no established ditch or no established drainage on this curve. So it's all running down. Traffic's utilizing the whole inside curve of that road. So we might have to go back in there and look at reestablishing a ditch with drainage. You always have to talk about drainage, the importance of drainage. And drainage is really important on our super elevations to make sure we're maintaining that inside curve to our roads and to keep the material up on our road. This will take us right into our next question. The public road should retain its normal crown shape while passing through driveways. True or false? Intersections are always tough too. And, getting back, whether we're talking about the super elevations or intersections, or we're going to talk about hills, it's important to note that, we've touched a lot. I've touched on all three of the previous webinars on the importance of having straight blades on your machines. And everywhere I go, everywhere I talk to, everybody I talk to, all these things that we talk about properly shaping, how we do our stuff, I always still like to stress the importance of making sure that we have good straight blades on our machines. The answer, go ahead, Catherine.
I was going to say the results are in, so true got 84%.
And it is true. The public road should retain its normal crown while passing driveways. And that can get to be a big thing. Anymore now, we're starting to get a lot of people that are moving out into the country. We're seeing a lot of nice fancy houses and everything built. And a lot of times when they build those and they shape our driveways, if our road's not in shape and we don't have it brought up and have the good crown to our road and stuff, a lot of times when they're building those houses and putting those driveways in, it exceeds out into our road. And when it does that, it can create its own series of problems. So we got to make sure that we maintain our crown through our driveways. Intersections can be difficult to maintain. We have controlled intersections and we have uncontrolled intersections. On a controlled intersection, the road still has to maintain its driveway. It has to maintain its profile through the crown. When the adjacent roads come up and they go to match that road, we need to begin to level out and remove the crown from the road. We don't want to totally remove the crown because we need to keep some profile to the road, some cross slope to make sure we still have drainage. But on a controlled intersection, the through road should always maintain its cross slope and its crown. And on the adjacent roads, we need to begin to flatten that out. On an uncontrolled intersections, all four ways that the intersection, as the roads approach the intersection, should begin to level out and flatten out. On that bottom picture, you can tell they still have the inside lines on the radiuses. We want to make sure we maintain some crown and we don't get lips and stuff in there because we don't want the water sitting on the inside of our intersections. We want to make sure we still provide drainage to that intersection, and we don't want it completely flat. Otherwise, the water will sit there and create its own series of problems. When we do this too, when we look at the controlled intersection, that's kind of like a driveway. The driveways are kind of the same way. We have to maintain that crown through our driveways and make sure that we keep the water back off the road. And a lot of times, we touched on this in our previous webinar when we talked about it. A lot of times, operators, they like to be cutting with that toe. They cut with that toe all the way till they get to that intersection. And then when they get to that intersection, they start to lift the blade because they don't want to cut through that intersection. So by not cutting through that intersection, as they raise the toe of their blade when they go to cross that intersection, they actually lose the material through the intersection. And when they do that, they begin to hump the intersections. If you're starting to see a problem with humped intersections and stuff like that, and we're getting that curb and gutter on the edge of our road, that's a good cause of it when we're doing that. When we come up to our paved roads, it's a lot of the same. We need to begin to eliminate the crown as we come up to our paved road. When we begin to eliminate our crown, it's a good method, kind of like our super elevations. When do we begin to change that transition? You need to kind of really look at a good 100 feet to 300 feet to start to eliminate that crown when you approach your intersections or your paved road. You got to give your operators time to take that crown out and to adjust it. And once again, we don't totally eliminate the crown. We still want a little bit left there for drainage. One of the important keys about when you come up to a paved road is there's different ways and different techniques out there that they show you how to eliminate the material. One is to gently roll your blade back and fan the material out. But if you do things like that, and when you work that material up towards your road, a good technique to use is once you get up there is to make sure you back blade the material back. Because too much loose aggregate at your intersections, especially coming off the paved roads, leads to a lot of washboarding and other problems like that. So we want to make sure we feather that material back by back blading it. And once again, about 50 to 100 feet to back blade that material back and not leave too much material at your intersections will really help you out with washboards and potholes. And the key is don't work this material up onto your pavement. And if you have the approach aprons, try to keep the material off your approach aprons, make it a good smooth approach into your paved road. All right, let's talk safety a little bit. I'm really key on safety. I really push safety, and it's really important to me. Hard hats. Hard hats are a big thing. I'm a firm believer in the hard hats, the use of hard hats. There's a lot of myths out there about hard hats. And so I just thought we'd throw a little bit in about hard hats. This will be our last one, some safety. I don't know how many entities out there actually require their operators to use hard hats. Your brain is an important piece, and it's a really important thing to take care of. And it only takes one time, and it could really change your life or affect things. When I was in the military, I know we always had to use our hard hat, and I'm a firm believer in them.
Okay. Well, I'll close the poll. And 83% said false.
And the answer is false. It is actually shown, there have been some different studies out there that your hard hat is actually 12 degrees cooler than wearing a ball cap. So it's really not too hot in the summer to wear your hard hat. And the way the liner is set up on the inside of your hard hat, it actually allows for circulation of air to get in there to help keep your head cooler. So if you're not using hard hats, I strongly recommend that you use them. They're really effective, and the key when we're out there is safety. Another thing that I want to address is hills. There's a lot of different ways to train for your hills out there, and there's some techniques out there that maybe need to be addressed. A hilltop should really maintain its crown through the crest and through the sag of a hill. When you take a look at a motor grader, if you go from the center of the front wheel to the center of your tandem housing on a 12M, it's only about 19.5 feet. Your tandems are made to pivot forward and reverse, but not side to side. So they're really made to compensate for when you go over a hill and different aspects like that. And when you take a look at most motor grader operations, they're happening probably between 3 or 7 miles an hour. So they're allowed to compensate for that. And you should really try to make sure you maintain your crown or your profile over or through the bottom of a hill. If you're teaching your operators to roll their blade back a little bit so they don't scalp the hill, or down in the bottom so they don't leave loose aggregate, there's a lot of different things that you could be doing. You know, if you're getting, when you take a look at the top of your hills, it tends to actually flatten your hilltops out when you do that. And you want to start getting that water to drain as soon as you can from the top of that hill off to the side, so it doesn't run down your hilltop all the way to the bottom of your road and carry the material down there. Plus, it's going to retain water while you do that. So a good idea and good technique is to make sure you always maintain the profile of your road through that hilltop. If your hill is steep enough that you're requiring your operators to roll their blade back so they don't scalp it while you're out there, you might need to take a look at that hill. Maybe there's some other things we need to do. Maybe we need to cut that hill down a little bit and shape it up and carry some of that material down to the bottom, because hills, they obstruct your vision, and steep hills and curves. So not only by building that up and taking some of that material off the top of that hill and filling in the bottom, you're going to improve the visibility of going over that hill. So if we could go to the next slide, Kath. So take a look at this hill here. And when we take a look at our road, you can see how our road is actually probably parabolic shape because we have the flat center. And when you take a look at the hilltop, we haven't maintained the profile through our hilltop. So we're forcing all that water to run down our hill. When it runs down through our hill, the road also hasn't maintained its profile through the driveway. So what it's doing is it's running all the way down that hill, it's hitting that driveway, and then where it hits that driveway, where the driveways build out into our road, it's actually forcing all that water across our road to where it's going to start causing that rutting and stuff in our road. If you take a look at right to the driveway on the left side, you can see once they've come down, they've got the shoulder cut down pretty good. So the water is getting over there, but there's also actually the curb and gutter on the edge of that road. So the water can't even actually get off the road. So when you look back at our previous webinar sessions, you know, the importance of being able to reclaim material, get rid of that curb and gutter to bring that material back up onto your road and reincorporate it into the road is really important. So we want to try to eliminate this. We want to try to eliminate having that water run down our hill to where it's draining off onto one side. So if we go to the next slide, Catherine. So once again here, when we take a look at this hilltop, you can see how we actually have the parabolic shape to our road. The center of our road is flat, and then once we get to the shoulders of our road, it drops off quite a bit. So the water, when it's coming down that hill, it's just following all the way down the hill till it gets to the bottom to where it's forced to wash off. And when it does that, it's going to carry our material down the road. It's going to retain the moisture in the center of the road, which is going to lead to rutting and other issues. And we really don't have much of a ditch here. We've lost our hinge point. We've cut our road all the way down. So we want to take a look at starting to bring that material back up to our road top, reestablish a good hinge point, narrow our road up. This road's probably about 40 to 45 foot wide. And we want to start bringing that back up, reshape our road, and once we get to the top of the hill, we want to make sure we maintain that profile through our road. All right, next slide, Catherine. True or false? If a motor grader actually causes washboarding, it is almost always the result of running at too great a speed. I wanted to throw this question in there, and it's something that we haven't addressed in our other topics, and because motor grader speed is always a big subject when we come out there and do training. So there's a lot of different things to look at when you operate a motor grader.
So 73% said true.
73% said true. It's actually false. There's a lot of things when it comes to what causes a motor to cause washboarding. Speed can be actually a minor factor when it comes to washboarding. With the advancement in technology and stuff, equipment and the power that it has, it can run at greater speed. When you're out there and you're training your operators and they're asked to do so much, sometimes we have to work at a little bit greater speed. One of the big things is you got to look at your tires. You know, what are you running for air pressure in your tires? What are your tire conditions like? A lot of it is machine settings. When we go back to some of the other techniques and stuff that we looked at when we were teaching, how you place your moldboard on the road. You know, if how you set when you go back and we talk about it, how you set your heel, if I can apply a little bit of pressure, where I'm running my tires at on the road. We looked at, how on an aggregate road, how traffic will displace material. How do I have my machine set? Where am I running my tires on the road? If you're running your tires on top of those little windrows they get made out there, that's going to lead to washboarding. What's the profile of my road? What are my blades like? If I got good straight blades on a road that's actually parabolic shaped and I go out there and start trying to cut, it's going to make that blade chatter. It's going to cause that hopping motion. Articulation. That is one of the biggest things I really like to teach when we're out there. Articulation really gives your motor grader a wider base to work with when you're out there. So there's a lot of aspects when it comes to running a motor grader. I know speed is one of the big causes, one of the big blames on it, but a lot of it can be addressed to how I'm setting that machine, how I'm running it, what air pressure am I running in my tires, and a lot of different aspects. So we go to the next slide. In closing thoughts, I just want to say it takes a lot of time, and it takes a lot of training. You just don't hop in a motor grader or get into road maintenance and you just don't learn it overnight. It comes by trial and error. It comes by allowing your operators to try the techniques, what they're doing out there. Always be pushing them to learn, always be pushing them to do professional development, and always be willing to try new ideas. And it takes everybody collaborating when they're out there to build a safer transportation system. From your LTAP centers to your management to everybody, it really takes everybody working together to build a good team, to get people on board, and to work with your operators. I was telling Catherine earlier, or not Catherine, I was talking to somebody else, but it's a tough job, and it takes a lot of time to get good at running a machine and how to shape it, how to set it. There's so much to teach and so much to learn that sometimes, when we're out there, we have to learn to be able to deal with the public, and we have to be able to keep those ideas out there so we can express and pass our knowledge on to them. Because a lot of times when I work with operators, they've got a tough job, and they catch a lot of heck for what they do. So they get to the point where they're scared to set their machine. I did a training not too long ago, and the operator had been in the machine for quite a while, and he didn't even know how to side shift his circle. He says because he was scared to do stuff because he was scared he was going to get in trouble if he tried something new. But allow your operators out there to try things. Take time to train them, work with them, and just it'll all work out. So we'll go next slide. Don't forget about these guys down here. When it comes to building a safer transportation system when we're out there, I know there's a lot of different aspects and stuff like that. These guys have good equipment, and you don't have to have a brand new piece of equipment to be able to do a good job. It makes their job more comfortable. You guys spend a lot of money on that equipment, and there's a lot to factor into your budget. But taking the time to properly train these personnel while you're out there really will add off in the end and the benefits for you guys. It'll really help you build a safer transportation system. It'll increase your productivity. But take the time. There's techniques out there. That's one of the reasons I kind of got into this on my own, to really go out there and spend the time with you guys, and not just your operators, but you guys, and really get the knowledge out there to really help build our transportation system and make it a lot safer. So, and then we can go to the next.
You have a question, Brian.
Okay.
So the question is, what is the proper tire pressure, and how does that relate to speed, vibration, and washboarding?
Proper tire pressure, you can go off, follow your manufacturer's recommendations. You can mess with your tire pressure a little bit. If you're having problems with loping and stuff, maybe move the tire pressure back and forth, maybe about 5 pounds. There's some different techniques out there and a lot of different programs I've seen about staggering your tire pressure and stuff like that. You can add a counterweight to the front of your machine, which will help to add a little bit of weight to the front of your machine. When I operated for a long time, and I operated a lot of different pieces of equipment from Caterpillar, John Deere, Volvo, Case, a lot of them, I kept it pretty simple. I kept 45 pounds in my tandems and 50 pounds in my front tires. And I didn't mess with it a lot. I didn't fight a lot of issues when it came to bouncing and stuff. When it comes to bouncing and doing a lot of that stuff, a lot of it comes back down to how you're setting that machine. When you go through machine settings and the techniques and stuff that we teach, there's certain ways that you place your moldboard on the road. Being able to keep a little bit down pressure on certain parts of your moldboard really helps stabilizes that machine, along with the use of articulation. Air pressure can be tough, but there's a lot of other things that factor your tires. The condition of your tires. Do I have a flat spot on my tire? Um, there's a lot of things that can affect your tires. Like I said, when it comes to motor grade or loping, it it's really how you set your machine, how you're training your operators. It's the profile of your road. Drive down your roads, take a look at them. Am I getting that true A shape to my roads? And it takes time to get there. You might be fighting a little bit of bouncing and washboarding. Is the road already full of potholes? Is there already washboards out there? Are you running a profiler on the front? A profiler on the front will help take those washboards out before you get there, so your front tires aren't bouncing. I like to keep it simple when I'm out there. I like to try a lot of new things, and it's kind of like snow removal. How do I keep that machine from bouncing in snow removal? There's people out there that say you got to leave that whole moldboard up, an inch off the ground. Well, leaving that moldboard up an inch off the ground isn't allowing you to apply any pressure. When you're taking the snow off of a road, if you can apply a little bit of pressure, it all comes down to making sure you got your road profile right. It comes down to making sure if I can skim and keep a little bit of pressure on my toe when I'm taking snow off, but keep my heel up a little bit, that little bit of pressure is going to help me keep from bouncing. There's a lot of different techniques and stuff like that out there when you're out there to do that stuff. So.
Well, we do have a couple questions come in.
Okay.
Should you post speed limits on gravel roads?
Do you post speed limits on gravel roads? That's a question you have to get into the MUTCD. I know that some county roads do post speed limits on them. Where I worked, we had them. Some didn't. You'd have to go through your state law. And what is your state law? That's something that you go through when you take your driver's license. What is the speed limit on a gravel road? And, the importance of, you take a driver's license test when you're 16. Do you ever take a refresher? Maybe we had to take a refresher course so people remember what the speed limit's supposed to be on a gravel road. If you're having issues while you're out there, make sure it's posted. But that's something that you'd have to get in the MUTCD. You'd have to talk to, your attorney. Do we have to look at posting the speed limits and follow what your state is recommending?
Okay. Another question is, what's a profiler on the front?
If Catherine could go back one or two pictures, I would show you what one is.
Okay.
It's right here. If you take a look at the machines here, this is a good setup. If you take a machine at the bottom left, that's a profiler on the front. It's a front mount machine and it's got the little rock bits in it. I know sometimes we run those rock blades, those rock bits on our moldboard, but when you do that, you're always busting the crust of your surface. And that leads to its own series of problems, something that we discussed about earlier. But if you can run that profiler on the front, that allows you to address your certain issues where you're coming up with washboards and stuff like that. When you get into certain parts of the year, when the ground gets real hard, depending on what you're running for an aggregate where it's limestone can get really hard without proper moisture when it gets dry. Those work really good. They have a carbide insert in them. You can set them down and they scratch the road surface, and they're really beneficial in taking out washboards and potholes. And the other thing that they can be used for is if you're fighting a lot of quarter crown in your road. When we get back into design and stuff, you can actually the way you set your machine is you can actually take that profiler, put it down on your quarter crown, and use that profiler to take that quarter crown, out a tenth or two at a time, while you can follow it up with a good, smooth, straight blade, so you can slowly start working that quarter crown out of your road. Because you can't take it all out at once unless you have the money in your budget to go out there and start re-rocking all of your roads. So a lot of things that we try to teach is we try to teach a difference between a road rebuild and how to do things as maintenance, because we got to slowly start bringing our roads back. We can't fix everything at once, but there's a lot of techniques and stuff that we can do out there as maintenance and preventive maintenance. Preventive maintenance is a huge issue when we're out there to keep our roads in the shape that they need to be. So, but that's what a profiler is. There's different kinds. That's a Caterpillar one. The Caterpillar ones, they're a little bit straighter in the front. The one I had on my John Deere, it had more of an angle to it. But as you notice on their profilers, though, one other thing I want to point out is notice how it covers the whole width of the machine. It goes, from the outside tire to the outside tire. So that's an important aspect too.
Great. What sort of grade should you carry on a hill that is 6%?
You're talking about your cross slope? if your grade, you're on a 6% grade downhill. That really varies. I always say if you could try to keep your operators between 3 to 5%, you might want to look back, going back down to 2%. If you're on a 6% grade, there's a lot of contributing factors there. 6% grade on an aggregate road is quite a bit. So you might want to look at, you don't want to run too much because you don't want to be getting your traffic off in the ditch either. You might want to back it back down, try to stay around that 3%. That's the recommendation. It's important though, when you go out there, to make sure that you're trying to keep that grade. Well, the other thing is too, is if you're going downhill, and you're running a 6% grade, there's a good chance that there's curves in that hill too. So you're going to have to look at it, am I insloping or outsloping my road, and stuff like that too. Is it a straight stretch? Is there curves in it? Like I said, most generally, if you're running 6%, there's going to be some curves in that hill, and then you're getting into where you got to start insloping your road and outslope, and eliminate maybe the center line cross slope.
Okay. Another question is approaching a T road the same as blading through an intersection? It seems like a lot of grader operators quit blading before they get to the T road.
Blading a T road is kind of the same as approaching a paved road. As you approach the T road, where the road crosses, it's much the same as a paved intersection. You need to begin to eliminate the crown on the road that's approaching the cross section, and you need to eliminate it and begin to eliminate it and flatten it out. But like I said, you still want to leave some crown in there, and you want to start about probably 100 to maybe 300 feet back, somewhere around in there. But it's much the same as approaching a paved road. You maintain them and profile them the same way.
Okay. Another sorry.
I was just going to say a T road's a lot like your driveways too. So, when you're blading through the road, that seems to be another tendency on a T road, depending on which direction you're coming from. If you go, I don't know if you could go back a couple screens, just a couple real quick, Catherine, to that paved road. A couple slides. That would help me explain it a little bit better. Right here. So this is pretty much a T road. This says paved road, but this is a T road. You want to begin to eliminate the crown, as you approach the through road. The through road maintains its crown. But what happens a lot of time is, even on a T road, when the through road that's going through, which is on this picture, is called the paved road, we cut all the way up to that T intersection, and then we lift our blades and we lose our material. So even at our T's, we begin to hump. But we want to maintain our profile through the paved road, that's our T road, and then on the road the adjacent to and one that approaches that, we want to begin to eliminate the crown.
Okay, wonderful. Another question is, do high vehicle speeds deteriorate gravel roads?
Yes, they do. Speed, that really throws your gravel a lot more, throws your aggregate, your rock, and that's important. Speed plays a contributing factor to things, and I know that it's a big thing when we're out there. One of the big things when it comes to speed, education. Do I post a sign? A lot of it comes back to education and making sure people are educated on the speed and the effects that it has on a gravel road. When it's a little bit wet out, people tend to slow down a little bit, even if you don't have enough aggregate out there. If the road might get a little bit slick, but it seems like the drier it gets, the faster the people go, which leads to more problems. But it does deteriorate, along with the weight of vehicles, the amount of vehicles they're getting, and a lot of different contributing factors like that. A gravel road, it takes a lot to maintain it. Just because you blade it once and you get it in the proper profile doesn't mean it's going to stay that way. It's a continuous maintenance problem, and that's where speed's going to throw your rock a lot farther too. That's where you need to look at incorporating a material reclamation program, to where you can start bringing that material back up on the road. And like all the dust that's flying away, that's our binder. That's important to make sure we're keeping that larger aggregate there.
And another question is, are the packers behind machines beneficial?
That can be to a certain extent. It depends on if you have the right proper moisture content when you're blading your road when you're out there. If you're blading a road and it's dry and you're out there and you've got a little bit of clumps and stuff, it's really not going to pack them down into your road. You have to have a good the Packers, the rubber tired ones, were really more designed for pavement, asphalt, and stuff like that. They can be beneficial to use, but you got to make sure you got the proper moisture content. Most places I go, they don't have a water truck. So, and then to have somebody to run a water truck out there while they're out there blading the roads, do you have a water truck that's going to be able to follow all your operators around? The expense of doing that, the expense of buying a packer. There's different things you could do with one. There were certain times I ran a packer. If I had a road in good shape and we got some good moisture, I would go out there and use the packer. And that's actually leads me to another really good point. If you're going to use a packer, you got to go out when there's moisture out there. You got to go out there when there's moisture in the ground. A lot of times I go out there, I do training, and we get that moisture, we get that rain, and everybody thinks it's too wet. I can't blade this road. I can't do that. But it's really important that you get your operators out there when there's that moisture there, because when it comes to cutting those potholes out and relaying that material down, you got to do it when it's wet. If you got a packer, that's going to help you out a lot. When it's dry, you can't leave all that loose aggregate out there. You might have to make a small windrow. There's a lot of different things you got to do when you're out there, but that was a really good question.
And actually, he has a follow-up question. Do you think using calcium chloride is beneficial for gravel roads?
It can be very beneficial. A lot of it comes down to your budget. Do I have the budget to apply calcium chloride when you're out there? The big thing about applying that is you got to make sure your road's in shape and profiled right and everything before you apply it. So, but it can be very beneficial. I know that it all comes down to budget. It all comes down to budget. In your budget, can afford it. A lot of entities, that they don't have in their budget. They struggle to get by with what they have. So.
Okay, we have another question. It's please address blade pitch and what that does for the material segregation and the ability to cut and fill the surface of the roadway. Does the blade pitch add compaction to the road?
Does the blade pitch, and to a certain extent, comes down to if you got moisture there. The more you roll your blade forward, the less cutting action that you're going to have with your board. Rolling your mold to a certain extent, if you're working in light material, will actually apply a little bit of pressure to your mold board, which will help keep that machine from bouncing out there when you're working in light, dry material. Blade pitch and angle are two of the toughest things to teach an operator, because you have to be able to pick your material up, especially if you're bringing it back from your shoulder. You have to get that going action road. Well, if you're trying to move material, it depends on what you do out there. If you're doing light blading action, doing a two-pass, you're going to roll it more forward. But the more forward you roll it, the less cutting action you're going to get. So it depends on what's size, what's the road in shape like? How's it shaped? Am I going to be out there trying to take out some potholes? So there's a lot of factors that contribute in to how you use your blade pitch or even your blade angle when you're out there. And am I moving heavy, wet material? I'm going to need that rolled back a little bit more. I can't roll it back too far, because if I'm trying to move too big of a windrow, it's going to boil up into my circle, and then it's going to boil over my mold board, and then I'm not going to get that rolling action. So it's your depends on how wide your machine is. Running the wider tires, are you still running the 14s? All those factors into your machine and what you're doing.
Okay. Well, there's no more current questions.
Okay.
Are there any final questions for Brian? And again, you can always contact me or Brian after this if something comes up that reminds you. Oh, we got a chat. Hold on. A question that comes up or situation, don't hesitate to reach out to Minnesota LTAP or Brian Jackson. We can get in contact with him.
So, and Catherine has my contact information. If there's anything you guys need from me or anything, feel free to reach out to me anytime. She has my email. Sometimes if you're maybe having some issues with the road or something, sometimes if you can send me a picture, that really helps. A picture, they always say is worth 1,000 words. If you have a picture you can send me, that really helps me look at what issues you're dealing with and different aspects of the road. So.
Well, I guess thank you everyone for joining us today. And if you viewed our other ones, thank you. They're going to be available for the foreseeable future. So again, if there's anyone that you know that would benefit from these videos, just pass that along to them, our website. Oh, we have one more question that just came in. Oh, thank you. You're welcome. We appreciate it. Again, you'll be receiving, as soon as you leave the meeting, evaluations form is going to pop up. You could do it right now or later. You'll get follow-up email with that link as well. So we appreciate everyone's time and feedback. And again, thank you for attending today. And if you need a PDH form or you want a copy of this presentation, please contact me and I'll provide you that information. Okay?
And I just want to tell everybody thanks and allow me to be a part of Minnesota LTAP and your Gravel Roads webinar series. This is our last one. So, but I just want to say thanks to Catherine for all her help, Minnesota LTAP, and everybody who joined, and thanks for the questions and everything too. So,
yeah. Well, everyone have a wonderful day. Enjoy the rest of the summer.